See. We'll see. Alright, first thing we're going to look at here is some basic addition of polynomials. I've got 2x cubed plus x squared minus 3x plus 4. When I add that, that's polynomial number 1, when I add that to x cubed plus 7x squared minus 2. I'm going to show you two different ways you can do this, and I don't care which method you choose. Either one of them is pretty easy. I just always choose whichever way it's already written. So if this was written like that, if I saw that and I was told to add, this is when I say I'm going like term hunting. So I get over here in this first parentheses, I got a 2x cubed, I hunt for an x cubed in the other parentheses. Is there one? Yeah. So 2x cubes plus 1x cubed gets me 3x cubed. Power stays the same when you add subtract. Okay. Now in the left I've got an x squared, so I got to hunt for an x squared in the other one. Yep, there's one right there. So I got a 1x squared plus a 7x squared. That gets me a positive 8x squared. Okay, now I've got a negative 3x. Do I have an x to the first and the other one? No. So negative 3x plus 0x just stays negative 3x. And then here I've got a constant. Is there a constant in the other one? Yep. So 4 plus negative 7 is negative 3. That's it. You can't simplify that anymore. Even though those are all x's, they've got different powers on them, so they're not like terms. So pretty simple on that. Alright, other way you could do it, same problem, you could stack them vertically. Okay, so there's my first polynomial. My second one had x cubed, so I'll put it underneath the x cubed. Positive 7x squared goes underneath. I'm putting them in like terms. This one didn't have an x, so I can either leave that blank or I can put a 0x there, either one. And then minus 7 was my constant. Okay, so this is the other way. Now this is just as easy, maybe even a little bit easier, but on this particular problem it would take me longer to rewrite them like that, so I wouldn't do that. I just usually do it however they give it to me. But here you just go, you got 2 of these plus 1 of these, that's 3 of those. 1 of these plus 7 of those, that's 8 of those. Negative 3 plus nothing, it's negative 3. 4 plus negative 7, it's negative 3. So you get the same answer. It's up to you if you want to take the time to rewrite it in your favorite method or just use whichever method it's already ready for. Easy schmeezy, huh? Alright, so you do this one. I want you to add negative 4y cubed. Where did it go? I lost it. Plus 2y squared minus y plus 2. Add that to y squared minus 6y plus 9. Go. Alright, you could go either method that you wanted here. Since it was already just written out horizontally, I would keep my preference, I would keep it like that, so I would do some like term hunting. So I got a negative 4y cubed. Is there another y cubed over here? No, so negative 4y cubed plus nothing just stays negative 4y cubed. Okay, now I got a 2y squared. Do I have a y squared over here? Yep, put the scope on that. 2y squared plus 1y squared positive 3y squared. Okay, now I got a negative y to the first. Do I have a y to the first over here? Yep, be careful on your signs. Negative 1 plus negative 6, negative 7. And then it looks like I got some constants left. 2 plus 9 is 11. Did you get it? Good deal. Alright, now we're going to do the same thing, but with subtraction. So it's just a little bit trickier with signs sometimes. You got to be careful when we're subtracting. I got 3x cubed plus 5x squared minus x plus 8. I'm going to subtract from that 5x cubed minus 4x squared minus 3x plus 1. Alright, again, you could stack them vertically if you want to. It's horizontal already written, so I'm going to just keep it like that. Just be careful with signs. This subtraction sign in front of that second polynomial means we're subtracting every piece of that. So I'll try to emphasize the signs as we go to follow those along. 3x cubed minus 5x cubed. So 3 of them minus 5 of them. Got a kid? Okay, now be careful here on your squareds. 5x squared minus negative 4x squared. Positive 9x squared. Y'all see that? 5 minus negative 4. So you have to do the minus and the sign in front of it. Okay? Negative x minus negative 3x. So what's negative 1 minus negative 3? Positive 2x. Good. And then on my constant, I've just got 8 minus 1. Just 7, that's it. Got rocking and rolling on some adding and subtracting. Alright, let's go to multiplication. If I've got x minus 2 times 2x squared minus 3x plus 5. I'm going to show you 2 different ways you can do this one as well. If this had been a binomial times a binomial, I without a doubt would be foiling. But it's not. It's a binomial times a trinomial. You can't FOIL when they're both not binomials. Because that second one's got 3 terms, it's a trinomial. So option number 1, the way I have it written, I'm just going to use distributive property. I'm going to take the first term here, and I always do the one and the smaller one, so the binomial. I'm going to take that x, and I'm going to distribute it to all of those. Then I'm going to take the negative 2 and distribute it to all of those, and then I'm going to combine any like terms. Okay? So we start here with the x. X times 2x squared. What happens? What's x times 2x squared? 2x cubed. Good. This, when you multiply and divide, is when your powers change. You add powers when you multiply. So that was an x to the first and an x squared. 1 plus 2 is 3. Okay, now I'm taking x to the negative 3x. So what's x times negative 3x? Good, good. Y'all are all right on that. Negative 3x squared. Now I'm taking the x to the 5. What's x times 5? Positive 5x. Now, when I get ready to multiply that negative 2 to everything, you can just keep writing it on out to the right of there if you want to. What I usually do, and it's just my personal preference, if I have a like term, I'm going to go ahead and put it underneath its like term. Okay, but you don't have to write it the way I do if you don't want to. You'll see what I mean here in a second. What's negative 2 times 2x squared? Negative 4x squared, and since I've got an x squared there, I put it underneath that. So I've already got my like terms matched up. But you don't have to do that if you don't want to. Negative 2 times negative 3x plus 6x. And then negative 2 times 5? Negative 10. Okay, so now the ones that I can combine, I've already got lined up there. I got to bring down a 2x cubed. Negative 3x squareds and negative 4x squareds gives me negative 7x.
So we're just adding?
5x and 6x.
11x.
11x and then negative 10. Okay, that's one way you could do that one. I'm going to do it a different way now. Y'all ready?
Same problem.
Yep, same problem. I'm going to do this one vertically. So I'm going to write my trinomial first. 2x squared minus 3x plus 5. And then my binomial underneath it, x minus 2. Okay? This is how you learn to multiply with things that had 3 digits and 2 digits when you were a little tot. You're going to take this negative 2 that's down here. You're going to multiply it times all 3 of those terms. Okay? So here we go. Negative 2 times 5 is negative 10. Negative 2 times negative 3x is a positive 6x. Negative 2 times 2x squared is a negative 4x squared. Now, when you were a little tot and you went to the next term, what did you have to put underneath there? A 0 or a placeholder. You could skip it and leave it blank or put a 0. I did the 0, so I'm going to put a 0. Okay, so now x times 5 is positive 5x. X times negative 3x is a negative 3x squared. And x times 2x is positive 2x cubed. So then, add those. And that should look pretty familiar to you if you look up at the previous problem. 2x cubed minus 7x squared plus 11x minus 10. Same answer, isn't it? Hope so, or I screwed up. Which way y'all like doing that better? I would do it just whichever way it was written again. I think they're both. I mean, you do the same thing in both of them. You distributed a 2 and a negative 2 and you distributed an x. So you do the same thing.
I thought I would line up.
The only way you line up wrong is if you forget your 0. Alrighty. Now, what if I needed to multiply x plus 2 times x minus 1 times x minus 3? What in the world's going on with that thing? There's no signs in between the parentheses, so it means multiply, multiply, multiply. What the heck? What we do?
You FOIL one of them and then...
Very good. So I can just start left to right and I can FOIL, because I got a binomial times a binomial. Then that's going to make my answer for that FOIL is going to be a trinomial. So then we'll have to then figure out how to multiply it to that. But here we go on the first two. First, x times x is x squared. Outer, negative x. Inner, positive 2x. And last, negative 2. Hello? Goodbye. Like terms there in the middle. Negative 1 plus 2 plus negative 1x plus 2x. 1x. Alright, so we multiplied those two together and we got a trinomial. But there's still a binomial out here on the end. Okay. What Macy's saying, she's going to rewrite it, put the x minus 3 over there in the front. Sure, not a thing wrong with that. Or you can leave it here and distribute from the back. I think that's what I'm going to do. It doesn't matter either way. Or, third way, you could stack them. So you got options on this. I'm going to take my x times x squared, x cubed, x times x, positive x squared, x times negative 2, negative 2x. Now when I take my negative 3, did Miss Slim do the way I do it? Does she line up the like terms or does she keep going out to the right? Or do y'all remember? Negative 3 times x squared, would she put that like I would underneath there? That's what I'm asking. Is that was okay. And then negative 3 times x is negative 3x. And then negative 3 times 2 is a positive 6. So now just add those like terms. I've got x cubed. 1 and negative 3 is negative 2. Negative 2 and negative 3 is negative 5 plus 6.
So whenever you get it there, you just add them.
Say that again.
So on the body, when you do subtracting them, you should add them to multiplication.
Totally different process on divide. What's the matter, Kylie? Alright, what if something said to do 4y plus 3 squared? What does that mean? A lot of us missed this in the last unit. Good, Caitlin. Means we got to take 4y plus 3 twice. Okay? And that's not too bad. I'm not going to foil it, so don't panic right now. I could foil that real fast and get a pretty good answer on that. That's not too bad. What if I needed 4y plus 3 to the third? Okay, and we just did a problem that had 3 binomials. That wasn't too bad, right? Okay, what if I wanted to do 4y plus 3 to the sixth? Okay, that's when it's getting a little bit more complicated. To write that out 6 times, three, 4, put 2 under here, 5, 6. Okay, you would get, if we did that, I'm going to show you another way to do this here in just a second. You would FOIL the first 2. Now, luckily, they're all the same. So whatever you get when you FOIL those 2, you're going to also get when you FOIL those 2, and you're going to also get when you FOIL those 2. But now that's going to make a trinomial times a trinomial times a trinomial. So that's going to be a long process if you had to multiply all that out. Okay? There's a shortcut that's sometimes hard to remember, but if you got it in your notes, it's not too bad. So first thing I'm going to do, it's off of Pascal's triangle. So I had one up earlier. Let me see if I can find it again real quick for you to copy. Oh, I shut it off. Let me get it up there. Pascal's triangle. Pascal's triangle.
Try alt click. Or right click on it. That'll get it moved in.
Try what?
Go back to the picture.
Yeah.
You can probably right click on it. Open a new tab. Do you see that somewhere?
Open link in new tab.
Open image. You need to open image. Yeah, right there. Go down. Go down. Right there. No, no, no. Right there. You can zoom in.
Alright. What you've got here, I don't know about Pascal, I don't study this a whole lot, but always starts with 1. Okay, then these numbers, you bring the 1s down, obviously, every time. Okay, see those are on the sides. But then this one comes from adding the 2 above it. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. Okay, and you can keep going on that. Okay, so if we wanted to make another row, it's going to be 1. Okay, then we've got 1 plus 7, and we've got 7 plus 21.
28.
We got 21 plus 35,
56.
6, and we've got 35 plus 35, and we've got 35 plus 21. See, they're going to start being images now. Then we've got 21 plus 7, and then you got 7 plus 1, and then you got your 1.
Wait, what is this used for?
Well, we're going to use it as a shortcut for multiplying binomials. I'm not real, we'd have to go back to that Wikipedia page and figure out what it was originally intended for. I don't know.
How will we use it?
I'm going to show you. Okay, but you might need to go, this is just in case you ever need to extend it. So you need to go ahead in your notes and get you a copy of Pascal's triangle. Pascal's triangle. Pascal. Those numbers out there on the side in the blue, that's just telling what all of the row adds up to. I don't care about that. If you've already written them, it's okay, but I don't care about it. Yeah, it doesn't hurt. All this book says is that Pascal's triangle is named after French mathematician Blaise Pascal, who lived from 1623 to 1662. It's not very long. He died early. He's too busy making up funny triangles. What they're going to say about Caitlin. Mathematician Caitlin Crane. Alright, y'all got it? Yes, no, maybe?
I got a box of
Oh, a lot of them don't put the boxes around it. It just helps it stay organized. Is the only reason some do. Alright, we'll get back on the smart notebook and we'll learn how to use that thing. Alright, turn the page. So I'm going to turn that book 7 times. I'm going to look at x minus 2 to the 5th power. I don't know what I just wrote. Erase that. X minus 2 to the 5th power. Now remember, your options are, you could write that out 5 times and start foiling and go to town with that, but we're going to use Pascal's triangle this time to do it. Okay? First off, since that's the 5th power, you need to go to the 5th row in Pascal's triangle. Okay, that's why you need to know to extend it, how to extend it, because you might need to go to the 12th row at some point. So now, before let me tell you this: that first one, that's row 0. Okay, so you might want to label that over there on the side of it. So it'll be 1 all by itself is row 0, and then go from there. 0, 1, 2, 3, 4, 5, 6, 7, and so on. Okay? So that's going to make a big difference. Alright, so you found your 5th row. Tell me what numbers from left to right are in your 5th row. 1, 5, 10, 10, 5, and 1. Okay, everybody agree so far? So far, so good. Those are going to be what the coefficients in my polynomial that I'm fixing to get her. Okay, so my I'm trying to think of the best way to say this without royally confusing you. Since this is a fifth power, the highest power that I'm going to deal with is a 5. So the power, this is going to be my, if I think of this as an A and a B, my power of A is going to start at the highest and it's going to descend. My power of B is going to start at the lowest and it's going to ascend, go up. So A's are going to go 5, 4, 3, 2, 1 down. B's are going to go 0, 1, 2, 3, 4, 5 up. Alright, so x minus 2 to the 5th. This is going to start with our first coefficient is a 1 times your A to the 5th. Now I'm going to write this time, but you're not going to write this ever again. Times your B to the 0. Okay, why did I tell you you're never going to have to write that again? No. What's anything to the 0 power? 1. So multiplying by another 1 there is not going to change that, right? Now one trick that I always use to check myself, because this can get confusing. When I'm doing my powers, they always have to add to that power, whatever that power is. So that helps keep me on track. 5 plus 0 is going to add there. So my next one, it's going to go down 4, up 1. That'll add to 5. So you can keep yourself on track there. Alright. So to my next term. Plus, what's the coefficient going to be on my next term? 5 times A to the 4th, because they're going down, times B to the 1st, because they're going up.
So we're just going to do this like if it was the 7 either down, the 37 either.
So that's how we'll know when we're done. Our x will be a 0. Okay, plus, I've done the 1, I've done the 5, so now I'm looking at this 10, right? 10x to the 3rd, negative 2 to the 2nd. Good, done with that 10. Oh, I got another 10. What's my x with this 10 going to be? 2. What's my negative 2 going to be? 3. Okay, is everything still adding to 5 on my powers? Yep. Okay, now I'm to this 5. I don't have enough room. I'm going to go underneath it. 5x, see, I was 5, 4, 3, 2. So this x is to the 1st. What's my negative 2? 0, 1, 2, 3, 4. Okay, and then I got 1 left. Plus 1x, and I probably won't write this in the future with you. X to the 0, because that's 1, right? Times negative 2 to the 5th. Alright, now we got to clean that mess up. I know that looks hard and that looks confusing, but it really is easier than writing out x minus 2 5 times and doing that, because we just pulled that off of the Pascal's triangle. Alright, so we got to clean it up. Here's what I'm talking about. Start on the left up here. Negative 2 to the 0 is 1. So 1 times x to the 5th is just x to the 5th. So this piece here got me x to the 5th. Done with that. Alright, let's go here. Negative 2 to the 1st is negative 2. So I've got negative 2 times 5, which is negative 10, and then there's still an x to the 4th there.
So you can combine that using our 5 with an x?
You can. They don't have to be like terms to multiply.
Oh.
Okay, so we're done with that piece. Everybody all right? Here I got negative 2 squared is 4. 4 times 10 is a positive 40.
Well, I have a question.
Yes, ma'am.
I thought if you squared a negative, it would be positive.
It would. Negative 2 squared is
on the
positive.
second one.
That was to the 1st. Negative 2 to the 1st. I didn't square it.
Oh, right.
If it's a negative number with an odd power, it'll stay negative. With an even power, it'll turn positive. And that's going to be big for us in a minute. So, all right. So we did negative 2 squared is 4 times 10 is 40. So we're done with that one. All right. Here, negative 2 cubed is negative 8. Negative 8 times 10 is negative 80. And here's what Kylie was talking about on this. Negative 2 to the 4th. Since it's an even number, that's going to make that a positive. 2 times 2 is 4 times 2 is 2 is 16. 16 times 5, I think, is 80. Is that right? Yes, so plus 80x to the first. Done with that. Negative 2 to the fifth. It's going to be a negative. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So negative 32 times 1 is just negative 32. Can't simplify that anymore because there's not any like terms. That's it.
You mess up with like one little spot.
Yep. Be the same as if you were writing it out doing the long
I
multiplication
can
though.
go into
Your powers should all, you're in standard form. 5, 4, 3, 2, 1, nothing. Mhm. I don't know another way.
Yeah.
I should have put this in the middle.
The one little page.
Yes, but now I won't go over.
Alright, let's do one where it's got coefficients on it. This one says, let's look at 3y plus 1 to the third. Alright, first off, I might not use Pascal's triangle on this. I might just write it out 3 times. But let's go ahead so we get practice using it. Okay? You got to find the third row on the triangle. So on the third row, tell me what the coefficients, what the numbers are.
1.3.
Okay? Your A is 3y. That's what's always, I wrote a B, doesn't but so it's always going to go what you're going to start with. That's why I called it the A, because it's the first letter. My B is my constant. Alright, so I've got 1 times A to the, what's my highest power? What am I going to start with? 3 times B to the,
Can you just put 1?
times B to the 0. I told you I wasn't going to write it, but I did again. Just want you to know. Okay, so it always starts on the highest A and the lowest B with your powers. That was this one. That was my first coefficient there. Alright, so we're done with that one. Now my next coefficient's 3, so I'm going to say plus 3 times A to the second, because my A's are going down, 3, 2, times B to the first. Now remember your powers, you got to add to the power. Our power's 3. 3 plus 0 is 3. 2 plus 1 is 3. So far, so good. Done with that 3. Now my next coefficient's a 3 again, so plus 3 times A. See, my A is 3, 2, so this one must be 1, times B to the 0, 1, 2. Done with that 3. Now I got a 1 left, so plus 1 times A to the 3, 2, 1, 0 times B to the 0, 1, 2, 3. Alright, this one's going to be a little bit trickier to clean up because our A had a 3 with it. It wasn't just a Y. So I know this piece is 1. I got a 1 there, so that's not going to affect anything. So 3 to the third. 3 times 3 times 3. 27. Y to the third.
So you just do the 3 with.
Had to go to both of them. 3 to the third and Y to the third.
I thought you just put
A and B.
Okay, we okay?
No. Hold up. Why do you 27?
3 to the third. 3 times
Oh,
3
I did
times
3
3.
times 3. Oh. Oh, the other one's doing just 3.
The other one's the A was a 1. So 1 to the third or 1 to the whatever did just say 1. That's why I wanted to do one where it had a coefficient on it this time.
So do you multiply first or do the exponent first?
Exponent, just like order of operations. Alright, so we ready for the second piece? This 1 to the first is going to be 1, so I'm not real worried about that. Then I'm going to do my power here. 3 squared is 9, so then 9 times that 3 is another 27.
So
And
you
it was
only square Oh, that's the one, Josie.
Yep, you got it. So 3 squared was 9, times 3 is 27, and then we squared our y. Done with that one. Whoops, I lost one problem. There it is. Okay, 1 squared is 1, so I'm not worried about that. 3y to the first is just 3y, and then multiply it by 3, so it's 9y. Good job. This one's easy here.
One and just
No.
one.
Just be 1, because this is 1 times 1 times 1. That's it.
Your phone's in.
Everybody got it?
We do whatever.
Yes.
Not a hundred. Not like 2 of 20.
Yeah, I think so. That's very beautiful.
First thing you have to do is write your triangle on there.
That's right.
Hey,
One non-factor, redo the coefficient at the constant, that's not one.
we're both, okay, we did a coefficient there, but both of them not 1, yeah. We could do that.
Wait, you want what to not be one?
Neither, he doesn't want anything to be 1. 2y plus 4 to the third. Alright, see if you can get that one. Go.
We're not going to do that. Do you want to do the triangle thing?
Yeah, use your triangle on this. You get practice using it. Now your B is not going to be 1 every time. That's what the difference on this one is. You're going to have
You probably love them.
Anything is 0.
correct.
Okay.
Like not really big, so. Anyway.
So you do this for what the when you're that you're going to have a 4. Because this is
Yes.
Good try.
Third, 2 to the third power. But not by 4. Because that's 4 to the 0, which is 1. And the 0 power is always 1.
And I don't know if it's the same. Okay. But 40, but, and then the 0 is 1. That was 0. I'm gonna get my own. Oh, wait, never mind. I was right. So you got A by Q given 64.
I haven't cleaned mine up yet, but I've got it set up.
Oh, I put it. There you go.
The questions that I'm hearing is just confusion on your multiplication and your powers. Do the power first to whatever you're getting the power with, and then multiply. You need another second still, or can I start cleaning up? Okay, no problem, no problem.
It's just confusing because usually when you multiply zero, it makes it zero. So it's weird that the power of zero is 1. Okay.
Alright, 2 cubed on this first piece is 8. Everything else is 1. Because that's a 1 and that's a 1, so it's going to be 8. And then I got a y cubed. So everybody get 8y cubed for your first piece? Okay, 2 squared is 4. Then I got to do times 3, which is 12. And times 4, which is 48. So you should have 48y squared on your second piece.
So you get your exponent comes from, your power thing comes from the first part, like you writing 30 down. And
Yeah, because on the constant where it's just a number, you're going to raise it to that power so it'll cancel out.
Oh,
So it'll
okay.
just be the one that sticks with the letter.
Okay, that makes sense.
All right, here this 2 stays to the first, so that doesn't change it. But here 4 squared is 16. So I got 16 times 2, which is 32, times 3, which is 96, and a y to the first. Good job.
Is it wrong to put y1?
No, it's not wrong. Okay, this whole thing, this is 1 times 1, because 2y to the 0 is 1. So 4 to the third is 64. How'd you do?
If it's not in order, oh, it should be in order.
It should come out in order, yeah.
But if it's not, would you have to move it around?
Switch it around, yeah. All right, sometimes, some years, we do a day where I give you like a huge one and give you the period to work on it, and we hang it up on a poster board. I don't know, we might do that someday this week, we'll see. But that one, like I said earlier, 2y plus 4 cubed, if it's just cubed, I probably would write it 3 times and do it. But once they get past that, I use that triangle. It's confusing if I just came in here and said, do 2y plus 5 to the 6th with Pascal's triangle, and you didn't have it to look at or go back in your notes, I myself probably wouldn't remember it. But you've got it, so you can look back at it and see where to plug stuff in and
If you
everything.
had like 3y plus 1 to the 4th, could you just do 4 like one time and then you just add them together?
You wouldn't add them. Then that would give you trinomials that you would have to multiply.
Oh, okay. You would distribute them.
All right, we'll call that a day on that. Good job.